Alright, do you have any questions on this?
Who's over like
8 or 9. Alright, well, we can do both of them. We got time. That's all we're doing today, so. Anything else?
I'm gonna get the right answer for
19. Okay. Alright, yeah, we'll look at it. What else? 14. Okay. Alright, let's work on these. If we have more, if we got time, we'll hit some more. Alright, let's do number 8 first. X over 6 over 7 over x plus 7. Alright, this is just this is a big division problem, isn't it? Alright, so it's just, what do? We take the top, keep it the same. Instead of dividing, what's the phrase I always use? Multiply by the reciprocal. That's right. So I take this and multiply by the reciprocal. Well, what's the reciprocal of this? X plus 7 over 7. Right? And that's basically it. What do you do to the top? You could distribute it if you wanted to, but you don't really have to. You can just keep it like that. Right? Because it's x times... Right.
Stop.
And then 6 times 7 is 42. That's your answer right there.
So you'll accept either one if you distribute
Or x squared plus 7x over 42.
If you have time, you can also do
7? Yeah, I would accept either one of these. But why bother doing this when I accept this? Wouldn't you agree? I would. If it was me, I would write it like this. Right? Either way, I give you credit. Doesn't make any difference. All right, let's do number 7. I'll tell you what. Let's do number 9 since we're kind of on the same. Sorry. Since it's kind of the same style of problem, we'll do number 9. 4 over p squared minus 81 plus p over 1 over p plus 9. Alright, here we go. Let's do this first. See this p? Just, I don't know if that makes it easier or not, but I'm going to put it over 1. Is that alright? Alright, so let's see what we can do. Look what else we can do up top here. What I'm going to do is I'm going to simplify that. So what's the word? Yeah, it's a difference of 2 squares. I'm going to factor it though, right? That's what I'm going to do. So it's 4 over, and it is a difference of 2 squares. Yep. P plus 9, P minus 9, plus P over 1. And then this is just 1 over P plus 9. We'll mess with that a little bit. Good so far? So the only thing we've done is just taken this and factored it. That's all I've done so far. Now what I want to do, I want to simplify this whole entire top right here. So what do? I got a fraction plus another fraction, right? So I'm adding fractions. What do I have to find? Common denominator. This is the easy common denominator because you got a 1 right there. So my common denominator is p plus 9, p minus 9. Now, did you have to do anything to this to get to this denominator? No. You multiply by 1 technically. So you multiply that by 1, that just stays a 4. Plus. Now, you had to take 1. What'd you do to 1 to get all this stuff right here? You had to multiply by all that stuff, didn't you? Alright, so what do we got on top? We got a p, and then we've got p plus 9 and a p minus 9. See what I just did? See, how did we get from 1 to this? Well, we multiplied by p plus 9, p minus 9. So you do the same thing to the top. So I've already got a p up top here, and then I multiplied by p plus 9, p minus 9. And it's all over that common denominator. 1 over p plus 9. Let's see. Let's do this. No, you can't cancel. I mean, like this p plus 9 and this p plus 9?
Never mind.
Well, we'll do it in a second. I mean, something will cancel, but we gotta we want to do the division thing first, okay? So now we're back up to here. Over here, that was the very first step, right? We just multiplied by the reciprocal. On this problem, we had to do a couple things before we got to that point. Now I can take, see this big division sign right here? Now I can take the top divided by the bottom. So let's take the top, which is 4 plus p times p plus 9, p minus 9, over p plus 9, p minus 9. All I did was just rewrite the top. Do you see that? I really haven't done anything. I just take the top and I keep it the same. But instead of dividing by this, what do? Multiply by the reciprocal. So it's p plus 9 over 1. Now look, this p plus 9 is being multiplied by all this stuff, right? So this p plus 9 will cancel with this p plus 9 down the bottom. Why does this cancel and this one doesn't? Because this is part of this product, which is part of this sum. You see it? So it's this plus this whole thing. So I can't cancel out this 9, p plus 9, but I can this. Because what's this p plus 9 doing? It's multiplying by all this stuff. You get it? Nothing's being added to this. It's only being multiplied by something. So p plus 9 cancels with this p plus 9. Let's see what we get. Now, if you wanted to, let's see how they write this. This is number 9. Yeah, let's write it like they do. It's going to be 4 plus. Now look. I'll just kind of do a little mini step right here. What's p plus 9, p minus 9? It's p squared minus 81, like we started with, wasn't it? Okay, but it's this times what? Times this p. So let's go ahead and write it and distribute the p out. Now, if you wanted to, if you just wanted to write p and then p squared minus 81, I'd be fine with that. But the answer key, did you notice in the answer key? They actually took the p and they multiplied it out, didn't they? Alright, so just for the sake of being consistent with the answer key, let's go ahead and multiply it out. So if I took that p and distributed through here, I would get what? P cubed minus 81p. Again, if you just wanted to leave it p times p squared minus 81, I'd accept that. That'd be fine. Because it's no more simplified that way. And then on the bottom, I got what? P minus 9. And that's it. Make sense? Same kind of problem as part A, wasn't it? Pretty much. Just numbers might have been a little bit different. That's it. You know, do those a couple times. You got a couple there. Okay, go in the book. Right? Take the book. Find what lesson that's on. And try to find an odd problem in the back. Because you got the odd answers in the back, right? Do one of the odd problems. There might be an example in the book or something like that. But I bet you'll be able to find a problem that looks like that in the book. Alright, so you work it out. See if you get the right answer. That's good practice for you. Okay, let's do number 7. Alright, let's take a look at this one. Now this is a subtraction problem, isn't it? I mean, that's eventually what you're going to do. But it's a lot more than just a subtraction problem. Because I got to find a common denominator. When I'm subtracting fractions or adding fractions, I need to find a common denominator. But the way the denominators are written right now, it's a little bit ugly. Right? So I can't really find a common denominator from this mess. Right, so they rigged this thing, didn't they? So I can factor them. And that's what we're going to do. So that stays on top. Let's factor this right here. Yeah, it's a difference of 2 squares. You're used to seeing that now, aren't you? So it's x plus 4, and it's x minus 4. Minus. This is just a regular old trinomial factoring. So let's put a couple parentheses. This is an easy one because they're both plus. So it's x plus what? Yep, x plus 4 and x plus 1. Right? Multiplied together is 4, add them up is 5. We're good to go. So now what we have to do is we got to find a common denominator with all this stuff right here. So let's see what we do. Let's see what we've got on both sides. Remember doing this where I had like forget that. Right, well, let's see what we got so far. We got an x plus 4 here, right? And we also have an x plus 4 over here. Well, we just have one of them, right? So I'm only going to use one of them. So I'm going to use an x plus 4. What else do I have? And that doesn't have to be on both sides. It doesn't have to show up on both sides. It just has to show up somewhere, either on this one or this one. What else do I have? I got an x minus 4, don't I? I don't have any here, so how many do I have? Just one of them. So I just use one of them now. Okay, what else do I have? and x plus 1. I don't have one here, which I don't need. I don't have to have them on both of them. It's got to show up somewhere, all right? Shows up right here. There's one of them, so I've just got x plus 1. That's my common denominator right there, all right? It's just like, well, forget it. I'm just going to go on. Sometimes I just go too detailed, and I got to stop myself from doing that. All right, so there we go. That's our common denominator. So what do we ask ourselves? We say, how do we get from this, okay, to this whole denominator right here? So I already have an x plus 4. I don't have to do anything with that. I already got an x minus 4. What else is missing? X plus 1. So I got to multiply this by an x plus 1. You with me? All right, so let's do that. Let's go ahead and distribute it out. Might as well. So that's what? X squared plus x. Okay, good. Now let's do the same thing over here. Let's look at this denominator. How did we get from this to this? That's right. You already got an x plus 4. You already got an x plus 1. What's the only thing that you don't have? An x minus 4. So I have to multiply this by an x minus 4. Everybody see that? Now this is where a lot of people might mess up. It's a minus, isn't it? All right. You got to distribute it through both of them. So it's minus 7x, and it's minus what? Negative 28, right? Because it's negative 7 times negative 4, which is what? Positive 28. A lot of people will put minus 28 on that, but it's positive because it's negative times negative, right? That's the thing that for years and years I've been teaching this, and that's where a lot of students go wrong. They forget to distribute that through there. And now we're pretty much done, aren't we? Just got to add some like terms together, make it look a little pretty. So what do we got? X squared minus 6x plus 28 over all this mess. X plus 4. Is that how they write the answer? Now what I would do, first of all, I would look though, I mean this kind of looks like it would factor, doesn't it? Does it factor? Oh, I don't think so. So what, I mean, what, 7 times 4 is 28, right? There's no way I can get 7 and 4 to be a 6. You got 14 and 2, which there's no way I can get a 6. What else? That's it, right? Yeah. Yeah, that's it. So there's nothing that works, all right? So I just keep it like that. Yep, that's exactly how they write it. And I just leave it just like that. You good? Yeah. And finding the denominators is not too hard. I mean, the hardest part is just factoring here to here, right? That's the most work. Okay, finding your common denominator, if you know the process, is really not that hard to do once you get it looking like this. And then I think the second hardest thing would just be figuring out what your numerator is. The rest is easy. Adding like terms, you just keep the bottom the same. Don't multiply the bottom out like that. Just keep it like that. All right? Okay. All right, here we go. We're trying to simplify this stuff. They actually kind of make this a little bit easy for you because, look, they got the x's on top of each other. They got the y's on top of each other. They got the z's on top of each other. It just kind of makes things at least look a little bit nicer. So what's the deal? I can't leave it like this, an x on the top and x on the bottom like this. So I'm going to have to either move this to the bottom and this to the top, or move them both, or whatever. Right? You could move them both. Right? Take this one, move it to the top. That would make it x to the positive 1/5. I could take this, move it to the bottom. That would make it x to the positive 7/5. Yeah, you could do that if you wanted to. You could also do it in one step. You could just take this, chuck that down to the bottom. What are you going to get? X to the what? 7 positive 7/5. Right? So that goes from on the top to the bottom. Look what I've got now. This becomes a positive exponent, doesn't it? So we'll deal with that in a second. What about this one? What am I going to move? Yeah, the negative 1/3 to the bottom. So let's take this, okay, chuck this one to the bottom, and I'm going to have y to the 1/3, and I'll mess with that next step. What about this one? Take that negative, right, and move it to the top, and so that would be z to the positive 5/6, right? All right, let's see what we get now. Let's do the top. Let's do the z's. So this is going to be z. Now what do I do with the exponents? If I'm multiplying these together, what do I do with the exponents? I add the exponents. So 7/6 plus 5/6 is 12/6. Well, what is 12/6? It's just a 2, isn't it? So it's z squared. Let's do the bottom. Let's do the x's. X to the 7/5 to the negative 1/5, what would that be? To the 6/5. That's right. X to the 6/5. And that doesn't simplify. Right? What about this? Add the exponents, 5/3. So it's just y to the 5/3. There's nothing I can do with that. And I believe that's how they write the answer, isn't it? What was it, number 14? Yeah, that's exactly the way they write it. That's it. That's not tough, is it? Just take the negative exponents and move it down. If they're both negative, I take the one that's the bigger number, okay? And technically it's a smaller number because it's negative 7/5, but I take this to the bottom. That becomes a positive 7/5. If I multiply them together, which means I add the exponents, it actually becomes a positive exponent. All right? You okay with that? All right, so that was 14. Let's take a look at 19. I'll tell you what, let's erase this mess. Do it right here. Okay. Let's see, 1 over square root of 5 plus 5 over square root of 45 minus 3 over the square root of 20. Alright, again, we got fractions, right? It's not the first time we've added fractions today, but we've got square roots, though, on the bottom, which makes it a little bit tougher, but let's see what we can do. I'm just going to keep all the the radicals down the bottom for right now when I add them together. Okay, maybe at the very end, then I'll rationalize the denominator. But for right now, let's just keep it like this. But what we have to do is we got to simplify this radical. Let's come over here off to the side. Square root of 45. So what I do is I think, what times what is 45? 9 times 5. And I use 9 times 5 because I can take the square root of 9 and I get what? 3, and then that 5 is still in the square root, so it's 3 squared of 5. So that's the big part of this problem right here, is that you need to know how to simplify that radical. Right? It's not so bad, is it? Turning it into 9 times 5? Okay, what about 20? Let's do that. Square root of 20. Let's break that down. Well, 4 times 5, right? You could go 2 times 10, but can you take the square root of 10 or the square root of 2? No, so I pick a number where you can take the square root of. So 4 times 5 works. Square root of 4 is 2, and then that square root of 5 is just like that. So the bottom is 2 square root of 5. That's your first step. Simplify this, simplify that. Right? Again, they rig them, don't they? Because look, they all have square root of 5. They make it so it works out nice and pretty for you. In that case, just practice on how to work with radicals. This is 1 over... Well, I'll tell you what, before we do that, we've got to find a common denominator, don't we? Look, I got a 1 square root of 5, I got a 3 square root of 5, I got a 2 square root of 5. What if I just had the numbers 1, 3, and 2? What would my common denominator be? It'd be 6. But it also has a square root of 5 in there, right? So it's 6 square root of 5. That's my common denominator. Does that make sense? Okay. Now, what do we have to do? We've got to ask ourselves a question, right? What did we do to this? Right. How did you get from this to this? What did you multiply this by to get to this? Well, what? Right. You multiply this by a 6. So if I multiply the bottom by a 6, what? Multiply the top by a 6. So I get a 6. 1 times 6. Put a plus because of this plus right here. Ask yourself the same question. What did you do to get from 3 to 6? Multiply by 2. So you multiply this by 2, and that gives you 10. We good? Minus. Okay, what'd you do to this? This 2 to get to 6. What'd you multiply it by? So you multiply the top by 3. This is a minus, so you put a minus, and then 3 times 3, and that's 9. Alright, let's see what that is. Well, 10 minus 9 is 1. 6 plus 1 is 7 over 6 square root of 5. But we don't leave it like that, do we? This is what, 19? Okay, just making sure they didn't leave it like that. They don't. Let's see. What do? We got to get rid of that square root of 5, right? Remember the rule? How can I get rid of that square root of 5? Yeah, bottom and top by the square root of 5. Because really, what are we doing? We're multiplying by 1, aren't we? So we can do that. We're allowed to do that. Let's see what we get. On the top is just 7 square root of 5. That was easy. On the bottom, what's the square root of 5 times the square root of 5? Just plain old 5. 5 times 6 is 30. That's it. Now they wrote it like this. But isn't that the same exact thing? Because look, what is, watch, what's 2/3 x? I'm just making up a number here. Okay, this 2/3 got nothing to do with this, okay? What if I had 2/3 x? Isn't that the same thing as saying 2/3 times x over 1? Isn't that the same thing as saying 2x over 3? So look, 2/3 x and 2x over 3 are exactly the same thing. Well, same thing here. Look, 7 over 30 times the square root of 5. What do? You just put it over 1, right? So it's 7 square root of 5 over 30, just like this. I like this way, but the book wrote it like this, but you got to, you just have to look at it and recognize that, oh, it's the same exact thing. It's no different. Right? That's right, because that's not on the bottom. Okay, it's kind of like 7 over 30 times the square root of 5 over 1. That's basically what they're saying right here, isn't it? You see that? And then if I multiplied across the top, 7 square root of 5, multiply across the bottom, 30, right? It's exactly the way I've written it. So either way would be fine. They write it like this in the answer key. I wouldn't. If I was to do this, I would do it just like I did it, okay? You got it? Does that help a little bit? Okay. Well, the part A is on YouTube. Now the part B is on YouTube. Okay, so all these questions we've gone over, that's what I would do. I would go over them. Maybe we hit some in part A that we didn't hit in part B, right? Make sure you go over those as well. It's only two days worth of lessons you really have to go over. If you're still not really sure about stuff, go back to the lesson where we actually taught it the first time and sit and watch them. Okay? But the best thing to do is not just to sit and watch, but it's to work them out. Okay? So, like if I did these problems before I watched the solution, I would write it down, try it myself without looking at the answer key, without looking at how I did it, try it myself, and then hit play, let it go through, and then see if you did the same thing that I did. All right? So when's the test? Tomorrow, right? My other class, my first period class, like, we're having a test tomorrow? I didn't know we were having a test tomorrow. And I'm telling you, you go back on my YouTube videos and look at it every day. I said, well, maybe that wasn't on the YouTube video because I think I said it before I started recording, but I did tell them every day last week that we're having a test on Tuesday. Even sent an email, even put it on digital lockers, everything. No, because we probably won't have school on Wednesday. All right, be ready for it. We should have school tomorrow. All right, because it's not supposed to. Snow's not supposed to start till later in the afternoon.
You somehow get out early, so
Right, exactly. So we're taking the test no matter what. So don't rely on the snow to get you out of it, because I'm telling you, every forecast I've seen, the snow is for towards the end of school. All right, so don't use that as an excuse. All right, that's enough of that.